Welcome to Architecting Software the SEI Way, Essential Steps Toward Mastery. Depending on your location, we wish you a good morning, a good afternoon, or good evening. My name is Shane McGraw, your moderator for the day, and I'd like to thank you all for attending today's webinar. We have over 1,200 individuals registered from over 70 countries for today's event. The webinar will consist of 3 presentations from SEI technologists on the latest solutions that are meeting the needs of our customers and partners in government and industry. Each presentation will conclude with an open dialogue period during which you can ask questions and learn more about how the SEI's work can benefit you and your organization. You can submit your questions to our event staff at any time during a presentation by using the questions pane on your control panel. We will address as many questions as time allows at the end of each presentation. For those of you using Twitter, be sure to follow at SEI News and use the hashtag SEI Architecture. Lastly, there will be a survey at the end of each presentation. We request that you complete this as your feedback is always greatly appreciated. Our aim is to make the day as convenient as possible for you, and you can log in to presentations as your schedule permits. We will do our best to start each presentation as scheduled. Our first presentation today is Software Architecture Fundamentals, Technical, Business, and Social Influences by Rob Wojak. Rob Wojak is a senior member of the technical staff in the Research, Technology, and System Solutions program at the Carnegie Mellon University's Software Engineering Institute, a position he has held since 2004. In his current position, he performs training and consulting in software architecture technology and software architecture evaluations. And now I will turn the presentation over to Rob Wojak. Rob?
Hi. Thank you, Shane. My name is Rob Wojak. I work in the Research Technology and System Solutions program at the SEI. The vision of the RTSS program is for us to enable assured and flexible system capabilities at all scales, with a focus on structure and behavior of software-reliant systems. There are a number of initiatives within the program. These are some of them. Architecture-centric engineering, system of systems engineering, and product line practices, with a number of areas also dedicated to advanced research and development. I work 99% of my time in the architecture-centric engineering initiative. And as Shane pointed out, I do consulting and related to software architecture, and sometimes I do training related to software architecture. Today we're going to cover some basic questions about software architecture. This is my presentation is meant more as an introduction to some of the key concepts of software architecture. And we'll cover what is the software architecture, why is the software architecture important, what are the requirements that are most important when it comes to designing a software architecture, and some of the other things that influence a software architecture that are above and beyond the requirements. And I'll take questions at the end of the presentation. Before we get started into the main body of the presentation, I'd like to know from the audience roughly what your experience level is when it comes to software architecture. So A, B, C, or D. A, I know a whole lot about software architecture, and down to D, what the heck is a software architecture? So I'll give you a minute to respond to the questionnaire, and then Shane will tell me what the responses are.
Okay, we're looking at about 50%. Rob looking like they know a whole lot about software architecture. 25% know enough to get by. 20% know very little. And 8.3, what the heck is software architecture?
Okay.
Back to you.
Great. So quite a few of you know something about software architecture, and hopefully I'll be able to pass along a few things to you. And for those of you that don't know a lot about software architecture, hopefully you'll get a lot out of this presentation. Now, what exactly is a software architecture? There are many different definitions for software architecture. Everybody and their grandmother has a definition for software architecture. If you were to go to the SEI website, you could not only see some of those definitions for what's considered to be modern definitions, classic definitions. We also have definitions entered by individuals from all over the world. You could go there yourself and type in your own definition for software architecture if you wanted to. Last I counted, there were over 200 different definitions for software architecture from everywhere. But of course, the SEI, we have the correct definition of software architecture, and that is software architecture is the structure or structures of the system which comprise the software elements, the externally visible properties of those elements, and the relationships between those elements. A software architecture includes information about what are the major elements, what are the roles and responsibilities and properties of those elements, how are the elements related to each other, and enough information to allow me to understand what the design decisions are that went into the architecture, and enough information to allow me to reason about the properties that are important to me when it comes to the architecture, and also to understand what the rationale is behind some of those decisions. And I was kidding that this is the correct definition. We like this definition because it focuses on the very basics of what a software architecture is, but there's certainly other definitions that sound just as good. Okay. Some things remain, regardless of the definition of a software architecture, some things remain certain. One is that software architecture is an abstraction of the architecture for the system. It's an abstraction that describes software elements. What is an abstraction exactly? An abstraction is something, it's a model of something. An abstraction shows important details and does not show unimportant details. When it comes to our software architecture, what are the important details? The important details are going to be those details that allow us to understand what are the design decisions that went into the making of the architecture and how those design decisions affect critical properties of the system that can only be achieved through architectural structure. So, software architecture is the abstraction that allows us to focus on software elements, the roles, responsibilities, properties, and behaviors of those elements. It allows us to address the relationships between the software elements. For example, which elements are related to each other? Why are they related to each other? How do those elements interact with each other? Why do they interact with each other? What are the mechanisms that they use to interact with each other? What are the protocols that they follow? What are the resources that they share? When we look at elements in an architecture, we look at them, we say from an external perspective. We want to know when we look at an element, what do we know about it from the outside? As an architects, we're not interested so much in the internal details of how an element is implemented. We're more focused, at least for the time, on what do we know about the element when we look at it from the outside? What functions is it supposed to provide? What properties is it supposed to provide? Like, how secure does it have to be? How available does it have to be? How usable does it have to be? Etc. Also, what else do we know about the element from the outside? What other elements does a particular element interact with, and so forth? The software architecture also shows us what we expect from elements. We call these the provide and require assumptions. When I go to use a software element, what can I expect from that software element? What can I expect from it with regard to functionality, with regard to other properties like usability, performance, availability, etc.? And also, what does that element expect from other elements in the system? We call these the provides and requires assumptions. The software architecture also shows the relationship to non-software elements. That could be the relationship of software elements to the hardware that it will run on, the relationship of software elements to various project teams that will develop those elements. It could be the relationship of software elements to external systems. Okay? Also, software architecture is described from many different perspectives. So at the SEI, I'm sure many other places, architects tend to be firm believers in documenting architectures in a way that it's actually useful. I'm sure many of you that are listening to this webcast right now have been in a position where you develop documentation about your architecture because the project schedule calls for it, not because the documentation is actually going to be used by anybody. So at the SEI, at least, we're firm believers in documenting the things that are actually necessary and the things that will actually be used. Step number one for us is to consider who are the stakeholders for the architecture, what do they need to know, what do they need to be able to do, and what properties of the system do they need to understand and reason about. After that, we decide which portions of the architecture need to be documented to satisfy those needs. There is not any one diagram or paragraph that we're going to produce that describes the entire architecture. An architecture is made up of many different structures, and many different people can take many different perspectives for those many different structures. Okay. Every software system has an architecture. Whether you know it or not, whether you like it or not, whether it's documented or not, whether it does its job or not, every software system ends up with an architecture. So, if you're developing a system, whether you consciously design the architecture or the architecture somehow evolves by itself, in the end, you will have an architecture. And one thing that should tell you is that if you're the architect for a system, and there are critical design decisions that you need to make about the architecture, and you fail to make them, somebody will always be glad to make those decisions for you. At the end of the day, you will have an architecture, and the question will be whether or not the architecture satisfies your needs. So if you're the architect for a system, you should identify what are the key design decisions that you make and make them. If you do not, you're likely to end up with an architecture that is not fit for your purposes. Finally, an architecture is not inherently good or bad. If you were to show me your architecture and say, is this a good one or a bad one, I cannot tell you without having you provide more information to me. And the key information that I need is stakeholder business goals and objectives. At the end of the day, my system is about satisfying stakeholder goals and objectives. If my architecture manages to help stakeholders meet their business goals and objectives, it's the greatest architecture on the planet. If the architecture does not help stakeholders meet their goals and objectives, it's a horrible architecture. So at the SEI and SEI methods, we typically start with stakeholders, stakeholder business goals and objectives, or a lot of times mission goals and objectives if we're working with government projects. Excuse me. Why is software architecture important? Software architecture is important for three primary reasons. One is it is a vehicle for communication among stakeholders. If you think about it, a software architecture provides the vocabulary, the very language that you're going to use to communicate about your system throughout the lifetime of the system. It's going to be the vocabulary that we use to discuss the requirements, the work that has to be done, the schedules that have to be put together. It's the vocabulary that will that will be used to name the project teams. It'll be the vocabulary that's used when the teams are discussing the project at the water cooler or over lunch or during team meetings. The architecture is a central figure in all the work and all the activities and all the discussions that will take place throughout the project for its lifetime. Second reason software architecture is important is the software architecture is the manifestation of some of the earliest and most important design decisions that will ever be made. Some of the most important design decisions that will be the most difficult to change as the project marches throughout its lifetime. The architecture itself, when I design an architecture, I design it so that the architecture, I can hopefully have any systems designed from the architecture meet certain properties. So I make design decisions that are consistent with achieving those properties. Then I turn the architecture over to the implementers. If the implementers follow my design decisions, there is some hope that the system that they're building will achieve the properties that it needs to have. If they do not follow the design decisions in my architecture, then all bets are off. I have no idea what properties will result from the system that they're building. So, we say that an architecture is not just descriptive. I'm not documenting my architecture for the sake of having an architecture documentation. We say that an architecture is also prescriptive. It tells people what design decisions that they follow. Or another way of saying that is that the architecture defines constraints on the way people can implement the architecture. Architecture relates to organizational structure in a number of different ways. Because architecture defines the actual implementation units that need to be developed, in turn, those implementation units are input into many different things, including things like the work breakdown structure, the project plan, the partitioning of an organization into different teams. It will determine which teams ultimately end up interacting with each other on a regular basis. It'll have an impact, consequently have an impact on which activities need to be performed. Everything from requirements gathering to design, to development, to implementation, to testing and maintenance. Architecture will have an impact on the structure of all these things and the work that gets performed and the resulting artifacts and activities that occur. Architecture will permit or preclude whether or not certain requirements are achieved. As we'll talk about in a few minutes, the whole reason we even take time out of our day to structure an architecture is to achieve certain kinds of requirements. In particular, we structure an architecture to achieve design constraints and quality attribute requirements. If we didn't have design constraints and we did not have quality attribute requirements, and the only requirements we had were functionality, we wouldn't have to worry about an architecture. truth of the matter is that functionality can be achieved with almost any architecture. So, judicious choice of architectural structure will help us to achieve important qualities. A wrong choice of architectural structure will prevent us from achieving certain qualities. Now, because architectural structure has a well-known impact on various system qualities, we can look at an architecture, the design of an architecture, before a system is even built and make predictions about what qualities any systems built from that architecture are likely to have. So it should be fairly intuitive to you that, and you've probably heard it all throughout your careers, that the earlier we discover problems with something and fix them, the less it's going to cost us. And this is the whole idea behind looking at one of the ideas behind looking at an architecture and making predictions about the qualities systems built from that architecture will have. We can look at an architecture long before we begin developing a system, try to make predictions about the qualities the resulting system will have, and make corrections to the design of the architecture before we begin development. Whoops, went one too far. Architecture allows us to control complexity. Software systems have always been very complex, and as the days go on, they become even more and more complex. There's no shortage of complexity in our software, and one of the things that architecture allows us to do is to control that complexity. The architecture partitions the architecture up into software elements, each having roles and responsibilities and properties that are key to achieving overall system properties. By partitioning the architecture like that, it allows us to get a better intellectual grasp on not only the requirements of the system, but the design of the system, how to build the system, test the system, and so forth. And having an architecture allows us to reason about and manage change. In general, having an architecture divides the world into three types of possible changes. There are local changes, non-local changes, and architectural changes. So that means that having an architecture and given a change, in order to accommodate that change, it's either going to require a local modification, which means one element of somewhere in the system gets modified to accommodate the change. It'll be a non-local change, which means that many elements will have to get modified to accommodate the change. And finally, there's an architectural change. An architectural change means there is a fundamental change to the structure of the architecture, to things like the elements themselves, to the communication and coordination mechanisms. It's a lot of cases it pretty much devastates the architecture. By knowing what your architecture is, it allows you to think about what changes can happen in a week from now, in 6 months from now, in 2 years from now, and ask yourself, if these changes occur, will the design of my architecture accommodate these changes? What type of change will adding a new technology be? What kind of change will adding support for a different foreign language have? Will it be local, non-local, or architectural? Based on the answer to that question, we might think about the design in advance and make changes to it to make to better accommodate changes so they're less costly in the future. Having an architecture allows us to develop what we call a skeletal system. A skeletal system is just what it says. It's a kind of a skeleton version of the final system. It's a kind of a working version of the system that doesn't do too much. The skeletal system has placeholders for most or all of the major elements of the architecture. those placeholders actually have connections to other elements. That means interaction and communication and control mechanisms between the elements. It's just that the elements themselves don't do all that much. Now, having a skeletal system up front, before we start to get into heavy development, pretty much helps the development teams to do all their work within a working system. Some of the greatest cost overruns in a system are, during the integration and testing phases of the system. Having a skeletal system, a working system that doesn't do all that much as early on in the development life cycle is likely to greatly reduce the time and the money that goes into integration and testing of the system later. So notice that the more I know about my architecture, the better job I can do at defining a skeletal system early. If I don't know anything about my architecture at all, it's impossible for me to develop any kind of working skeletal system. Okay, and this last point should go without saying. Architecture provides a sound basis for cost and schedule estimates. The more I know about my architecture, the better job I will do at estimating the cost and schedule of the system. What I can do with my architecture is partition different pieces of the architecture across my project teams, have the individual project teams do estimates for their pieces, and then roll those estimates up. That's a lot better approach than not having an architecture and then asking people to do a cost and schedule estimate for the system. Finally, software architecture is important because it's a transferable, reusable abstraction of a system. The words software reuse have been around for a long time. They've probably been talking about reuse since the 60s. And the problem with a lot of reuse over the years has been that reuse, a lot of times, is opportunistic reuse. That is to say, people develop a piece of software and they think, hey, this software could really be reusable. Why don't I put it into a big reuse library and hope that somebody comes along and finds it and then reuses it somehow? So that's kind of a short description of opportunistic reuse. I don't have any real reuse plan in mind. I just kind of throw things into my reuse library and hope somebody finds it. On the other hand, if you take time out of your day to do a good job at designing your architecture, describing your architecture, wouldn't it be nice if you could use that architecture or reuse that architecture on similar systems? That's part of the idea behind reuse within the context of a software architecture. By allowing your architecture to define a context within which reuse occurs, many things become reusable besides just the architecture that you defined, and many things become reusable besides any code that gets developed. Because you allow the architecture to define a very specific context within which reuse will occur, other things become reusable. For example, the requirements for one system might be reusable on the requirements for a similar system. The work breakdown structure for one system might be reusable on a similar system. The project plan and schedule for one system might be reusable on another system. The same tools, methods, techniques, processes for one system maybe can be reused on a similar system. But the whole idea here is that I'm taking my architecture and I'm allowing it to kind of be the stake in the ground around which reuse will occur. Anything that I get reused will be reused within the context of this architecture. And in a lot of ways, that the whole subject of architectural reuse, that is a big part of what we call software product line architectures. How do I take an architecture and reuse it on a family of similar systems? Okay. Let's move on to which requirements are most important to architectural design. So I divide the world into three types of requirements, which I'm sure a lot of you do too. We have functional requirements, we have design constraints, and we have quality attribute requirements. Quality attribute requirements, at least for all practical purposes for this discussion, are the non-functional requirements of the system. Things like performance, availability, usability, interoperability, portability. Take your favorite word and put Elicitation to the end of it, and chances are that's in somebody's requirements document as their quality attribute requirement. My favorite one, it has been for years, is webifiability. The system shall have webifiability. So when it comes to the design of your software architecture, what is going to determine whether or not these requirements are met, and which requirements, functional requirements, design constraints, or quality attribute requirements should you take into consideration when structuring your architecture? So what I want you to do is take a second to consider this. What if you were presented with a design for a system that has one big module that has 2 million lines of code in it? And I'm going to take that module and compile it into one big object module. And I'm going to take that one big object module and compile it or link it into one big executable. In the end, the software performs every function that I want it to perform without any problem at all. What's wrong with this design? Is there anything wrong with this design? Would you sign up to be a developer on this project? Would you sign up to manage this project? And if you think about it, the answer is probably no, because systems are not just about functionality. There's a lot of other qualities of a system that need to be satisfied. Which requirements do you think would be negatively impacted by this design? Well, the answer is probably just about all the quality attribute requirements. One big module would not make for a very buildable system. If I have one source file, how am I going to have a team of 20 people working on that source file? Modifiability would suffer. The module would be difficult to test. The module would be extremely complex. It'd be a nightmare to maintain. And so forth. I won't read the entire list to you. But the point is this. If functionality is the only thing that matters when it comes to developing a software system, any architecture will do. It is not the functional requirements that drive the structure of the architecture. It is the design constraints and the quality attribute requirements. The whole reason we even provide any structure to an architecture is to achieve things like modifiability, portability, interoperability, performance, usability. Okay, now, and certainly design constraints are important too, but here's the problem. People are generally good at figuring out what the functional requirements are. They're generally pretty good at understanding what the design constraints are. People are really terrible at understanding what the quality attribute requirements are for a system. And yet, quality attribute requirements are absolutely critical to the design of an architecture. So, some of the problems that arise when it comes to people specifying their quality attribute requirements. We have what we call non-operational requirements. I'm sure most, if not all of you, have heard requirements like this before. The system shall be easy to use. The system must have high performance. The system must be portable. The system must be highly available, highly usable, whatever. These are what we call non-operational requirements. They sound like requirements, and there's probably some detailed requirements buried in there somewhere, but these requirements as they are absolutely useless to me when it comes to designing a system. I have no idea how to design a system to be highly usable, highly portable, highly modifiable. Those are all very meaningless terms. And yet, you see requirements, quality attribute requirements specified in requirements documents like that all the time. The other problem is, when it comes to collecting quality attribute requirements, is that people debating which category a particular requirement belongs to. So I had a customer a few years back. They had a requirement that the system must process 10,000 messages per second. If I talk to one group of people at the customer site, one group of people would say, oh, 10,000 messages per second, that's a performance requirement. If I talk to another group of people, they would say, oh, well, that's a throughput requirement. If I talk to another group of people, they'd say, well, that's a capacity requirement. And if I put all three groups of people into the room together to discuss the requirement, instead of discussing the requirement, they argue over what to call it for an hour. Okay, so that's another problem with quality attributes, arguing over which category it belongs under. Finally, a final problem with quality attribute requirements is people using the same word to mean different things. So, for example, everyone knows what high performance means. Well, high performance to one person might be the system does its job within 1 second. High performance to somebody else might mean the system does its job within 1 millisecond. Okay? But the problem is we walk into a room and we say, how many people think the system should have high performance? And everybody says, yeah, high performance. Okay, great. Let's go start developing. And everybody does. Except everybody's developing to a different version of what high performance means. Okay, so these are typical problems that arise when it comes to collecting quality attribute requirements. And we actually, when we do training with people and consulting with people, we actually help, we provide some techniques for people to do a better job at collecting those types of requirements. And we also show them how to use those requirements as input to be effective at using them as input into the design of an architecture. Okay. Final thing I want to talk about today is what else influences software architecture. So, most of the time, people do collect their requirements and they start to design their systems. But the truth of the matter is that what's in the requirements documents are not the only things that can influence the design of an architecture. So again, requirements are not the only thing that influences the design of the architecture. It's important for you to understand that. There's a number of other technical, business, and social concerns that will ultimately impact an architecture. The better you understand that, the better you will be able to watch out for those things, the better you will be able to predict and manage change throughout the lifetime of your system. So let's look at some of these influences. First of all, in general, stakeholders are a huge influence on an architecture. Stakeholders, before I said, no architecture is a good one or a bad one until we shine the light of stakeholder goals and objectives on it. If an architecture helps stakeholders meet their goals and objectives, it's a great architecture. And if it doesn't, the architecture is terrible. So stakeholders have a lot of concerns that are above and beyond requirements. Customers, for example, are concerned with things like time to market. How much is the system going to cost? Users are concerned with will the system have all the features that I like? Will I have help when I need help? Either online help, or what about some kind of phone support? How will the phone support people interact with the system to support users? Managers have an interest in amortizing the cost of the development over the lifetime of the system. Managers have an influence in making their people happy, making sure the architecture uses new technology, for example, that keeps their people interested in. What person's going to stay in an organization where all the systems in this organization are going to be developed using object-oriented COBOL for the next 25 years? I'm not going to stay there. I want to learn new technology. I want to build my resume up. So managers are interested in seeing new technology being introduced into the architecture sometimes. Marketing people are interested in features of the system that'll be better than what the competitors are providing. Developers have an interest in what kind of technology, languages, and so forth that are being used in the architecture. Maintainers want to know that the system is going to be easy to maintain, configure, add features to, and that sort of thing. So these are all things that you're not necessarily going to find in the requirements document. But a lot of the things that I just mentioned are going to be directly related to the ultimate design of the architecture. Development organization can influence an architecture. For example, a development organization might have many either immediate or long-term business goals. For example, a development organization might be interested in making sure that the system that you're developing makes use of all the legacy systems that we have laying around, or at the very least interacts with the legacy systems. The development organization might be influenced by political concerns. Let's say you have managers that are fighting amongst each other to get ahead. Or let's go to the national level. What happens if Congress decides to cut the military budget or cancel the funds for my project? Again, the development organization is interested in keeping people employed. Right now I have a database team that's sitting down the hall from me that doesn't have a project. And I would really like to put them to work. You know what I think our system needs? I think it needs a database. Okay? The database will allow me to put those people to work. So, organizational structure will also have an impact on an architecture. So, is it any surprise to you that if in my organization, I have a user interface team and I have a database team, that the system I start developing a month from now, oh my God, it has a user interface component and it has a database component in it. A lot of times, the elements in an architecture mirror the organizational structure and vice versa. The organizational structure can mirror the structure of the architecture. Okay, again, I'll repeat that these are influences that you are not likely to find in the requirements documents. These are things that you have to watch out for above and beyond the requirements. The technical environment can impact an architecture. So, I'm sure most of you, if you think about it over the course of your careers, have been pushed into the position where you have to use the latest and greatest buzzword in your architecture. Who knows? It could be use object-oriented. I don't even know what it is. Just make sure you get it in there. Or World Wide Web. There's hardly a system that goes by today that doesn't have to accommodate the World Wide Web somehow. Your manager goes off to a conference on intelligent agents for 2 days and comes back, and the next thing you know, you're programming intelligent agents into your architecture. Can't use stupid agents anymore. You have to use intelligent ones. service-oriented, J2EE. This is all the latest and greatest buzzwords that you have to put into your architecture regardless of whether or not it's the right thing to do. Okay, and finally, another influence on the architecture is the architect's background and experience. If an architect has a good experience using a certain design approach, the architect is likely to use similar design approach in the future, whether it's the right thing to do or the wrong thing to do. If the architect has a bad experience using a particular design approach, the architect is less likely to use that same design approach in the future, whether it's the right thing to do or the wrong thing to do. So say, for example, an architect tries to design a client service system and it's a miserable failure. When the next project comes along, even though client server might be the best way for the system to be designed, the architect will likely avoid it simply because he or she had a bad experience on the previous project. Okay. Let's move on. There's a flip side to the coin. So architectures are influenced by requirements, but also by technical, business, and social things. But on the other hand, once a software architecture is in place, the software architecture will influence the technical, business, and social environment, which will in turn influence future system building. So let's give some examples of that. So let's say I develop a software architecture. The software architecture itself can affect the structure of the organization, which I've pointed out a number of times. The software architecture will affect the teams that are put together, work breakdown structures, project plans, project schedules, etc. The software architecture can also affect the goals of an organization. So a successful architecture might cause the development organization to move into developing other similar systems because of the success of the first architecture. A failed architecture might cause a development organization to move away from developing similar systems in the future. Architectures can influence stakeholder requirements. So, for example, an architecture may come along, or something that would have a significant impact on an architecture might come along. Say, for example, like .NET or Corba or who knows what. Again, this could be like the buzzword thing. Stakeholders like customers, users, whatever, they hear about these things. They don't even really know what they are, but they want them into their systems. Because having these things in their systems somehow gives them a level of comfort. They feel like they'll have a better quality system if they have that .NET thing or that Corba thing or that service-oriented architecture thing or whatever. So a lot of times, stakeholders will ask for these things, or they're willing to, and they're also sometimes willing to relax existing requirements if you'll give them some of these things that they didn't originally ask for. Okay. Architectures can influence the technical environment. A lot of times an architecture or something that will have a really big impact on an architecture comes along and will be in the technical environment and influence many systems for years and years to come. So let's just take a fairly recent example is that the World Wide Web. This World Wide Web thing has only been around for about 20 years. The World Wide Web has introduced itself into first of all, it was an architecture that came along and it evolved over time, of course. And the World Wide Web has introduced itself into the technical environment in a way that many, many systems for years and years to come will have to take this World Wide Web thing into account when they're designing their systems. Or some of the other examples that I have up here, let's just focus on one because I'm running out of time. Relational databases. Relational databases have been around for well, last I checked, 350 years. And there's hardly a system that goes by today that doesn't have some kind of relational database aspect to it, and that the architects of the system don't have to take this, they have to take this into account somehow. And finally, architectures can influence the background and experience of an architect. This is the flip side of the coin. Bad architecture is input into the architect's experience and actually to an organization's experience. The architect and an organization are going to avoid doing things that were failures on other systems in the past, and they're probably going to use things that they had success on for future systems, regardless of whether or not they're appropriate. Okay. So, again, I'll repeat. The important thing here is that as an architect, you need to understand that the requirements in the requirements document are not the only thing that will influence the software architecture. There's a lot of other things in the technical realm, the business realm, and the social realm that will impact your architecture, whether or not you want to admit it or not. So a smart thing to do, and actually I have a customer that does this, they, once a year, at least once a year, they sit down and they ask themselves, they call in some of their technical people, and they brainstorm about what are the things in the technical, business, and social environment that could ultimately impact their architectures? And they take that information back to their organizations, and they take it into consideration when they're designing their systems. So understanding that there are other influences besides the requirements helps you to manage change throughout the lifetime of the system. Okay, to wrap this up, I'm a couple minutes later than I wanted to be. Software architecture is important. Whether you know it or not, every software system has an architecture. If you're the architect and you fail to make important decisions about the architecture, you will end up with an architecture anyway. Quality attributes are critical to the design of your architecture. You have to know what the quality attribute requirements are. Traditionally, people are terrible at collecting quality attribute requirements. You need to be better at that. And again, requirements are not the only thing that influence the architecture. Okay. For more information, you can pick up this textbook by my colleagues at the SCI. And actually, I think in the very near future is going to be the third edition of this book, which I happen to be in the middle of reading, and it's an excellent update to that edition. And now I will have a few minutes for questions and answers.
Okay, before we start our question and answer session with Rob, I wanted to remind everybody to please fill out the survey that will appear on your screen at the end of this session. We'll push it live. Lots of questions about our slides available in a recording. This event is being captured, so it'll be available for review sometime later this week. The slides are actually available now on your console. If you look on your control panel within your console, you'll see a tab for download slides. So there's a PDF version of each presentation here. So you can download those now. So first question for Rob from Jonathan asking, details may be important or unimportant for different architecture purposes. So do you know what to include or exclude? Does show versus contain apply so the view of an architecture could still show important details for one purpose and hide others for other purposes?
So that's a very good question, and I could probably spend 20 minutes answering the question, but it boils down to this. And this kind of comes from Paul Clemens. Paul Clemens, he kind of jokingly says, it's architectural if the architect says it's architectural. And I think what he means by that is that there are all kinds of details that we could write into the specification of the architecture. There could be what people call high-level details, and there can be really, really low-level details down to the code level. The truth of the matter is that here's my rule of thumb and my quick answer to this question. If you're an architect and you're about to write down a design decision on a piece of paper, you have to ask yourself a couple of questions. And one question is this. If I do not write this design, is this design decision critical to achieving quality attribute properties of the system? That's question number one. If the answer is no, you probably shouldn't be too worried about it in the first place, in most cases. If it is critical to achieving quality attribute requirements, the next question you should ask is, if I do not write this design decision down, do I trust the people that come after me to make the correct decision so I will get the desired quality attribute properties of the system? If the answer is no, I do not trust the people after me to make this decision, then you should write the decision down. So let's say, for example, a quick example. I would really like my designers to use a kind of a common air handling mechanism throughout the system. And I know my project team, I have been working with them for 25 years. I know that they know that. I know that they know what the code handling mechanism is that we use around here. I'm not even going to bother putting it in the architecture document because they know what to do. I trust them to make the right decision. On the other hand, if my project team consists of a bunch of people right out of college, they've barely worked on a project in their life, they have no idea how to deal with the common air handling mechanism. The only way I'm going to guarantee that I achieve my quality attribute properties with relationship to the system is if I document in detail exactly how I want the air handling mechanism to work, tell my junior developers to read through it, make sure they understand it, and make sure they implement it exactly like that. So the details that I write is really context dependent. If I'm working on a system by myself, I'm not going to document every detail about the architecture because it's only me on the project. If I'm working with a bunch of senior developers, I'm going to go a little bit lighter on the details sometimes and a little bit heavier at other times. If I'm working with a bunch of junior people, I'm going to probably put a lot of detail.
Okay, next.
Oh, and the last thing I want to say is that some people at the SCI, it drives them crazy to use the phrase detailed design. Because saying detailed design implies, in the same sentence with architectural design, that's what drives people crazy. Detailed design implies that architectural design is not detailed. So there are some people at the SCI that would like to eliminate the words detailed design from the English language and other languages and divide the world into architectural design and non-architectural design. Because both architectural design and non-architectural design can be very detailed depending on the context. I hope that answers your question. Go ahead.
Okay, this may be a similar question to that, but from Daryl asking, would you consider architecture to be synonymous with what often is called high-level design?
Architecture is designed. First of all, let's just start with the word design. Design is about making decisions. And the question is, what kind of decisions am I making? At the architecture level, I am making design decisions that are directly related to achieving certain properties of the system. In fact, I could say at the architecture level, I'm making design decisions about how to achieve properties that can only be achieved through judicious choice of architectural structure. On the other hand, what people typically refer to the detailed design level, well, detailed design, that's about making decisions too. It's about making other types of decisions about what algorithms to use, what data structures to use, that sort of thing. Typically, at least in our world, we think about detailed design as being those design decisions that are not going to have a drastic impact on the quality attributes of the system. So both high-level design, architectural design, whatever you call it, that's about, it's about making decisions about what is the design going to be to achieve certain qualities.
Okay, we've got about a minute left with Rob here. A question from Johannes asking, How can I convince my design engineers to follow the decisions of the architecture when the architecture itself is not important for them or affect them directly?
Baseball bat. That's a really tough question. And I guess my immediate answer for that is it has to cost somebody something to not do it that way. You got to find out why it's important to them. It's going to be important to them in some way or another. And chances are for at least from your short description there, the chances are the cost to them is going to be how much pain and suffering they're going to go through when they have to rework the system when it's not done properly in the first place. You have to find out why it will be painful to them if they don't do the architecture. If you cannot convince them it will be painful to them, they will never do it. And that's my short answer.
Okay. That's all the time we have for this presentation. Rob, thank you very much for your excellent presentation.